So we get in there. So we've got 2 for a first prime number. Then we said 3 was the next prime number. Then after that, we said 5. And then we said 7, yeah? So let me start writing them so at least you can see them. So we went 2, first prime number. 2, then 3. Then someone told me 5, yeah? Then 7. What's the next prime number? Sorry? 11. And then 13. And then 17, yeah? 19. 23. Yeah. 3 times, yeah. So if you get a number in your head, for example, like 21, add the 2 digits. What happened when you do 2 plus 1? 3, that's a multiple of 3. So these are the wee tricks sometimes to use. So if you want to know a multiple of 3, add the digits. And if it ends with 3, 6, or 9, it's a multiple of 3. If it ends with 18, add the 2 digit, 8 plus 1, 9. Okay? So 21 is not. So after 23, 29, yeah? 29, yeah? And then 31. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. So now, did I tell you I only remember the first 2? The rest, I'll write them in a sequence. Can you see a sequence here? Yeah, so what sequence do you have here? What's 2? Sorry? What's 2 times 3? 6. That's why I only remember the first 2. What's, oops. So we said 6. 2 times 6. 3 times 6. 4 times 6. Can you see the 6 time table? Yeah. So apart from 2 and 3, all your prime numbers are going to be before the 6 time table or after the 6 time table. If you remember that, it's a good trick for you not to have your memory having to remember a lot of numbers when you don't need them, because you've learned the 6 time table at school. When you are at primary, it's easier to remember the 6 time table and picture it and see the number before it and the number after it than having to remember them by heart. Okay? So you'll find out if you Google prime numbers, any number you see, if you add 1 to it, it'll be a multiple of 6, or if you take away 1 to it, it might be so it's either before or after. Okay, so it's a good trick to have, because like I said, tricks, you'll remember them for a long time. Things like you don't need, you won't use, you probably won't remember. Okay, so I can go on forever. Obviously, you might say, yeah, but what about 25? Some of them would be the exception to that rule. So for example, 25 is not a prime number. So you know that you can take it out easily. Okay, so some of them might not be. There'll be multiple of 7 or multiple of 5 or a multiple of 13. But every prime number, if someone comes and said to you, oh, I think 611 is a prime number, put that in your head and say, okay, is 612 a prime multiple of 6 or 610 a multiple of 6? Yeah, so you go 612 or 610 because it's 2 of them. So you check if one of them is a multiple of 6. Is that a multiple of 6? So it's even Yeah. And it's a multiple of 3. Because 6 plus 1, 7 plus 2, 9. So that is a multiple of 6. So there's a good chance 611 is a prime number. But I don't know my prime number right up to 600, but I can tell if this number is a prime number or not. So you're at the point where you're going to have to give your answer, what we say, simplified to their maximum. Yeah. So if you get a fraction, you need to be able to simplify it. If you get a prime number in your numbers, that means you can't simplify further. So it's a good one to know. If you've got a square root of a prime number, it's a sod. You can't simplify it. So prime numbers are the backbones of a lot of mathematics, sequences and numbers. So you should be good with your multiples and you should be good with your prime numbers. And I've taught you 2 things today, how to figure them out and how to find the multiple of 3s, yeah? What do I do to find a multiple of 3? I just add all my digits. Yeah. And how do you find your multiple of 9? Do you know your 9 timetable? Do you see a sequence on your 9 timetable? Yeah. Do you see a sequence there? What happens if I add the 2 digits? What do I get? A multiple of 9, if you add the digits, will always end up with 9. Okay. Obviously, if it's a multiple of 9, it will be a multiple of 3 as well. But it's good to know if a number can be divided by 9. Yeah. If you don't believe me, try 6, 3, 3, 4, 6. So that's a multiple of 9. What's 6 plus 3? Plus 3 plus 6? 18. Now, remember I said it always needs to, you keep adding. What's 1 and 8? So now type that 6336 divided by 9, and you'll find out it should be a round number because 6336 is a multiple of 9. Another trick to have in your bag, yeah? Because one day, if you get something like this, I don't know, 18 divided by 6336, you need to simplify this. And you know 8 plus 1, 9, or 18, 9, or I can divide both by 9. So you'll do that, you will get, this is 2, and then this is 3,100 and I don't know, so you've got a 3 here. Is that 183? Something like that. 6336 divided by 2. 3168. Yeah, 3168, sorry. So do I leave it like this? Because they're both even. Then that means you can divide both by 2. And at this stage, you need to write as 1 over 1584. And this is how you leave your fraction. Yeah. To its simplest form. But we started with massive numbers. We didn't know what to do with them, but we noticed that we can divide them both by 6336 divided by 9. 704. That should have been 704, guys. Need to keep me right. 2 over 704. Because I've divided that by 9, remember? Or 9 over 3168. I should have done. And then that would be 1 over 352. You need to correct me, guys, if you see me writing something that you don't Trust. Okay. Remember, I'm a human after all. I will make mistakes. But the good thing is, when you see a mistake, you correct it. I notice it because I went, I've divided that by 9. I should have divided that by 9. Okay. So let's move on to the second topic. So you've learned quite a few things today. And that's what you're here for, guys, to learn things. Remember, so whatever you do, or whatever we'll do, hopefully you won't see as, oh, we're wasting our time. I'm giving you tricks and tips that will help you in the long run. It could be in your science subjects, in your math subjects, but that's what you need to grab from someone. Yeah, a teacher I've worked with these quite a lot to find these tricks. It's not a teacher at school that told me all this. I went and find out myself. And I thought, oh, that's a good trick. So why don't share it? Okay. So today we will investigate graphs. You will look at a graph, f of x. We're going to add or subtract a number from it. That'll be the first type of graph that we will change. The second graph is we're going to look at x when we change x with x plus and minus k. What does it do to the graph itself? Then if we take the inverse of f of x, or if we take what we call the negative of f of x, I don't like to use that inverse because inverse is f to the power minus 1, remember? So if we take the negative of f of x, what do we get? What do we do to the graph? If instead of negative of f of x, we take negative of x, so you'll be given a graph f of x, and you'll be asked, what does it look like if you do f of minus x? And the last one, we're just going to do k of f of x or f of k of x. So you've got 1, 2, 3, 4, 5, 6 different graph transformation. Some of you told me that they've done higher math, yeah? You've done that at higher math, yeah? But it's just trying to call back all that stuff that you've done. Let's see. So these will move the graph, like I just said, and they will get moved a certain way. So let's see if we can find out which way. I've been given this graph, f of x, yeah? It's got two, what we call turning points. Turning points just means when the graphs reach a high and then goes down, and a minimum turning point and go back up. So that's what we call them. And someone asked me, what if I do f of x plus 5 to this graph? What's going to happen to the graph? It goes up. Because think, this is the y-axis, right? F of x is normally y. Now, I've just told you, take y, any y, and just add 5 to it. So if you take any points here and you add 5 to it, so this point will move 1, 2, 3, 4, 5. This one as well, 1, 2, 3, 4, 5. So you can see what we've done to the whole function. So if we were to do it to each point, the graph would just go up. So that's why we say when you add a value to your function, it just slides the function up. So think about it if you were, I don't know, to do, you've got some audio system and you're asked to put to shift the function up because you want another function. And that shifting might be you tuning onto another, you know, turning a knob by delta of 5. That could do that to the function, for example. Okay. Now, if I've got a function where you're asked to add or subtract x, y, now x stays the same. So as you can see, all my x's have not changes, but it's the y that moves up or down, okay? So now if I've got this function here, f of x, and I ask you to represent the same graph, but f of x minus 3 this time. So what's going to happen to the function? Instead of going up, it's just going to go down here. So every y that we had, we do minus 3 to it. So 2 minus 3 will become negative 1. Here I've got 0 for y. Both will go to minus 3. And the function will just drop down to here. Yeah, easy enough. Add, move up, take away to the y, move down. That was the first one. The second one, so key points for the first one. If I was to summarize that, we move the original graph vertically up or down, plus move up, negative, k, move down. And like we said, only the y coordinate changes. And if you were given a graph with some coordinates on it, what they want you to do is take those coordinates and change them. And you need to put the coordinates, the new coordinates, where x stays the same and y changes. So let's have a look at an example. I've got f of x here. I've been told to do f of x minus 2. So remember, we've got these points here, these 3 points. What we called roots are where they cut the x-axis. And this is sometimes the y-intercept, but as you can see, it's as well a turning point for our function. Now, if I write f of x minus 2, so I've got negative 1 here. So I've got negative 1 here, negative 2 here, plus 1, plus 2. So take away 2, negative 1 will move to negative 3. And those zeros will just move to negative 2. Okay, fair enough. Now the points I was mentioning earlier on, so I need to write coordinate x, y, negative 1, negative 2. Here this becomes 1, negative 2, and this one x equals 0, y equal negative 3. So you just give those 3 points, and that should be enough. Let's have a look at this time a sine wave. Yeah. How do I know it's a sine wave? The sine wave starts at 0. Okay, sine 0 is 0. That's how I remember it. Whereas cos 0, the cosine, is 1. It's the complement. So here I've got a half here. So it's a half of sine x, for example. It's got 180, so half of. So I can put 2 of these within 360. So that's half of sine 2x, basically. Okay, but they've not asked me to talk about the wave itself, but they're asking me to add 1 to the sine wave. You take every point, you move it by 1. So if this was 0, this will end up the 1. This was half, 1.5, 0 goes to 1, negative half will go to a half, yeah? And that's me. I've added 1 to it. And all those points now have moved. Okay. So the points I had was 45 degrees, 0.5. Now it became 1.5. This will become 90 and 1. And this one, 135 and a half, yeah? Remember, you can write it as a half or as a fraction. To me, I don't mind. Whatever you feel more comfortable with is fine. But in scientific term, you will see people using more fractions. So if you see me using a fraction instead of 0.5, it's just a nicer way to write it. Okay, so we've looked at f of x plus or minus k. Now we're going to do f of x, but instead of the y, it's the x that's going to be plus or minus k. Okay, so let's see what it does to the function. So if I ask you to now redraw this, but doing x minus 2, what's going to happen to the function? It goes, yeah. So it goes on the right. So when you take away this time, remember, it's easier when you add, it goes up naturally. You think anything that you add will go up, take away, whereas it's the opposite. When you take away on x, you move to the right, whereas when you add, you move to the left. Okay? So it's just the wee things to juggle. So basically, it's just going to move to the right on the x by 2. So if I was at -2, I'm going to be at 0. Here I was at -3, sorry, -5, move to -3. Here I was at -4, move to -2, and then you redraw the graph. Okay? So to map it, in this case here, I've been asked to do f of x plus 4. So I'm going to move it to the left by 4. So every point, I'm going to move them by 4. And then you end up like this. Okay. So key points to remember for a graph where we change x within the brackets, we move left or right. To move to the left, it's when you add, and to move to the right, it's when you take away. Okay, so -k, move to the right. So only x is changed and the y doesn't change. If we purely move on the left or the right, the value on y stay the same. Okay, so remember we looked at f of x on its own, we've added or take away, then we've done f of x plus and minus k. Now, what's going to happen to the function if I take the negative of the function? So it was y, and now any y, I'm going to make it negative. I'm going to change the sign for the value. So think about it. If this was -1, what's going to happen to -1 if I take the opposite of -1? +1, yeah? So this one should come over here. This one was -5. So it's going to be +5. So that point now become that one. This one was 0, stays 0, because negative of 0 is just 0. So this will stay here. This one here was -3. It becomes +3. So as you can see now, if I was to take every point and do its negative, it's going to look like this. So what have we done to the function? We've flipped it. It's a bit like we've taken the mirror image of the function. So that function now, we say it's flipped in the x-axis, or we've taken the mirror image of it. So if you're asked to map xy, remap it into x minus y, you just use that x-axis here, and then you flip your whole function across, okay? And for this one, if I was to flip it, anything that was positive will become negative. So you will just go like that for the flip function. Okay, so we've looked at 1, 2, 3 cases where we change the graph. Key points again, flips the original function in the x-axis, or do the mirror image. Same thing. The y coordinate changes sign, that's all. Now, if I've got a function like this, and I'm asking you to draw minus f of x for it. So what did we say we do? We take every value. So the first one would probably be this one. The negative 1 will become positive 1, will arrive here. This one won't change. This one won't change. And every one of these will just go there. And this one will go to the negative. This one will go. So basically, you can see if you were to flip it, it just goes like this. So you just flip the function. Okay, so that's minus f of x. So 1, 0 and minus 1, 0, they've not changed. They're still there. But this one, this point here has changed. It used to be 0, negative 1. Now it's 0 and positive 1. All right. Let's have a look again at our sine waves. So sine wave, if I'm asked to do minus fx, you just flip. So whatever was there will become there, and whatever was at the bottom will go at the top with the same kind of amplitude. Yeah. So that becomes that basically. That points came to that points. That point stayed, and this new points is just 135.5. Okay, quite a few. So we've looked at minus f of x. What if it's f of minus x? Think about it. We flipped, taken the mirror image on the x-axis. Now what we're going to flip it against in the y-axis. Yeah. So f of minus x, instead of flipping it on the x-axis, we're going to flip it on the y-axis. So this point here on -5 will be the same point, but on the +5. Flip in y-axis, put a few points to help you, and just redraw it. This one again, we're going to flip it on the y-axis, and it's going to come in here. Flip in y-axis. +3 becomes -3, +5, -5, +4, -4. And that's what we call f of minus x. Flips on the y-axis. X coordinate changes sign. So how many have we looked at? 1, 2, 3, 4, 5, 6, 5. So f of minus x, we just said we're going to flip on the y-axis. Yeah. So this point will arrive 5 here. This point will arrive 5 there. This one won't change. So it's just the graph that will just change like that from there to there. Okay. That's f of minus x. Whereas minus f of x, we take the flip on the x. Right. Couple of points. So we've looked at moving up or down, moving right or left, flipping on the x, flipping on the y. Now what happened if I put a factor in front of it? So if I had f of x, let's say you do 2f of x. So any value of y basically would double. So what's going to happen to the graph? It's going to expand here. So the graph will expand. So 2f of x, for example, we will stretch it across the x-axis. So anything that is 0 will stay 0 because 2 times 0 is still 0. But if you had 2 here, the 2 will become a 4. The -2 will become a -4. It's a bit more than -2. Here you've got 2.5 will become 5. So you can see what happened. We've just stretched our signal. Okay, so again, you could be looking at sound and then you stretch it by increasing the power of it. So you'll hear the sound becoming a bit louder, but that's all they do into the sound. They put more energy to it. And the vibration, I've got the same frequency so that will hear the same noise, but louder. And that's all they do by increasing the volume. Decreasing it, instead of stretching it, it will compress it. So you'll hear the same voice, but less loud. And that happens if K, for example, is less than 1, then that means you're gonna half it, for example. We can put K equal 0.5. So you half the signal. So here I've been asked to do half of f of x. So we're going to compress it instead of expanding it. So the 2 will become a 1 and the 0 will stay at 0. So we've just compressed that signal. Okay. So important, when k is less than 1, it will compress it. If k is more than 1, it will increase the signal. Okay, so stretch, compress, depending on the value of k. Key points for that one. And the last one is instead of k f of x, is f of kx. So instead of stretching it now or compressing it, we're going to expand on the x because we've been stretching on the y. Now we're going to expand on the x. And that's where if you use like a signal, that is how you would change the frequency of the signal, for example, by expanding it or compressing the signal. Okay, so if I'm asked to do f of 2x, this time we compress in the x-axis. Okay, so when we were compressing y or expanding it, here when you go with a value bigger than 1, you will compress it. So you can see that now all my signal have been compressed. So the -4 went into a -2. So it's 1 k of x. Okay. So if I've got a signal here and I'm asked to compress it, but this time taking half of it, so it's the opposite of compressing it. This time it's going to expand it because I've got a value less than 1 this time. So it's a bit like whatever we do on the y, we do the opposite on the x. So we will stretch it this time. So that signal where I had 1 will become a 2, the 3 will become a 6, the 2 will become a 4, and so on. But that's if you use a factor of 0.5x. Okay. So key points: stretch, compress the graph in the x-axis. And the factor that we stretch or compress by is 1/k. So if k equal 2, it's a half. If k is 0.5, it becomes double. So technically, we need to be able to work with combinations. What do they mean by that? So we can have a look at some examples. Let's say I've got a function here. I'm asked to do 2 times fx, but then add 1 to it. So we need to see what happened to the function when we merge all these different ways. Okay, so if I'm asked to do 2fx plus 1, Okay, let's have a look here. So you flip in the x-axis whenever you've got a minus fx. So it's negative fx, we flip in the x-axis. If it's f of minus x, we flip on the y. So we've looked at that. We move up or down if we've got plus or minus k. We move left or right when we had x plus or minus k. We stretch and compress in y direction, and f of k of x, we stretch and compress in the x direction for this one. So let's have a look. Let's say we take this example, right? So we've got this function, and we've been asked to do f of x plus 1 and then add 2. So you look at the first one, x plus 1. X plus 1, we move to the left or the right. Because it's add, we move to the left. Yeah. So we're going to move to the left by 1. So every point here move to the left. And then we add 2. Adding 2 to the function moves it up by 2. So we've got a combination of those two here, left and up. Okay. Let's have a look at a different example this time. Here, I've been asked to do minus fx and then take away 2. So minus fx flipped in the x-axis. So we flip the function in the x-axis. So that point will go there, that point will go there. And then we move it down by 2. So you always deal with f on its own, and then you look what you do to it at the end. So we flip it, and then we bring it down. And that's what the end function will look like. Okay, so next example, we're going to take this one, f of minus x plus 1. So f of minus x, we flipped on the y-axis. So we're going to flip this function on the y-axis, and then we're going to add 1 to it. So that's us, we flipped it, and then we're going to move up by 1. Next. Here, I've got negative f of x plus 1. So x plus 1 tells me I'm going to move to the left by 1, and then minus that. So minus f flips in the x-axis. So we're going to move by left, flipped on the x, and then bring it down by 3. So you've got 3 things here combined. So let's do the first one. Move to the left by 1, flip it across your x-axis because of that minus, and then move it down by 3. Okay, so just combination of each, and then you can now put your points once you're done. This one here, I've been asked to do 2fx. So we said we expand it. So that's going to be twice the function, and then you add 1. What adding does, we'll move it up by 1. Okay, couple of points. And now the last one, we are doing f of half of x. So we said whenever we're going to have f of k of x, we're going to stretch or compress. Because it's on the x and I've got a value less than 1, we're going to expand it or stretch it on the x. And once it's stretched, we're going to move it down by 1. So this becomes stretched and then move down. So I'll send you the PowerPoints, and then that means you can use it and then play it in slide mode or presentation mode, and try and guess where should he go first? What do I need to work on first? But a good rule is to deal with x's first on the function before you add or take away, move up or down. So usually move up or down, you'll find out you'll do it at last, basically. Okay. And put some points for this one. So this diagram shows the graph of y equal f of x. If someone asked me to sketch the graph y equal 2 minus f of x, so minus f of x, we said we flip it. So minus f of x will be there, flip it in the x-axis. So we need to flip it in the x-axis first, and then add 2 to it. See that 2 in front is the same as plus 2. Then it goes up. Okay, so it's been flipped and then added 2 to it. So this point here, so you've got a translation. This one, I've got f of x minus 1, so we're going to slide it on the right by 1. Whereas this one there, we flipped it and then we brought it down. These are just examples. So again, some examples that you could play with and see where you would put them. A few more examples. I've put quite a few examples. Yeah, so let's have a look at this example. This is an interesting one. So this, you would look at a function, right? X squared minus 4x plus 5. So if you're asked to represent this function, what could you use to represent it, for example? Remember doing quadratics, parabolas, so on and so forth? Remember doing completing the square in math, Nat 5? Yeah, so if you can't find a root, you'll say, okay, if I complete the square, I'll be able to find what my turning point is going to be. So to complete the square in a function like this, you take this number here, -4, and you half it. So if I half -4, what do I get? What's half of -4? -2. So you would rewrite this as x minus 2 square. But then we need to compensate, because remember, we need to get plus 5. So this will add a 4. So to take away the 4 that we've added, we take it away and we put plus 5. So the plus 5 is this 5 here. Because we've added the 4. Remember, that would be x squared minus 4x plus 4. So we need to take that away. And then you just add the last 5. And that will become x minus 2 square plus 1. Yeah, so that's how you complete what we call completing the square of a quadratic function. Now, if I'm asked to sketch f of x, I've got what we call a turning point when x equal 2, f of x equal 1. So that's the minimum that you can get for that function, because you've got something square plus 1. Every number that you square will always be positive, right? So basically that one is my minimum turning point. It's going to be the lowest value of my function. And that happened when x equals 2. Now, when x equals 0, you cross this y-axis here at 5. So you can draw this f of x. Now, if I'm asked to do 10 minus f of x, so you flip the function on the x-axis first to do the minus f of x. then this 2, 1 becomes 2, negative 1. And then you add 10 to it because it's 10 plus 10. So and then that'd be your final function in red. So that's how you would draw your first graph, draw your second graph. Now, if we're asked to find the range for which this new function is positive, so there's my new function, 10 minus f of x. If I'm asked to find when is this function positive, so technically you would draw this, yeah? And that means you need to solve that new function equals 0. What's 10 minus f of x? 10 minus x minus 2 square minus 1. So to solve this, you just write it's x minus 2 square equal 9, because 10 minus 1 is 9. Yeah? Or x minus 2 equal plus and minus 3. Could say that if x minus 2 square equal 9, then if that is 3 or negative 3, that will work. So you can solve it like that. X minus 2 equal plus and minus 3. That means x equal negative 1 or 5. So my value here are negative 1, and this will be 5. And we've solved that. And 10 minus fx is always positive when I'm between negative 1 and 5. So that's where the function is always positive. So the y value is always positive between those 2 points here. And that's how you would just say the answer. Okay, so you need to be able to manipulate graphs. You need to be able to remember how to complete the square in this example. Okay, but you're not going to get example that complicated. But you can see the step-by-step that we've used through the graph transformation. And that is NAT5, that is NAT5. And like I said, there's not just one way to solve this. Yeah, instead of 10 minus x minus 2 square minus 1, I could have used just 10 minus here, x squared plus 4x minus 5, and solve that. That would be another way of doing it. Okay, so don't worry about this one. So the next worksheets that you need to work on would be worksheet number 5, page 51 to 53. So you'll see the questions, the type of questions. They're not as complicated as the higher question that we did. They'll show you the graph and they'll ask you to sketch the new graph. Okay. And if you struggle, you can look at the back of the paper. You'll be able to see, you can mark yourself by just checking the answers at the back of the paper. Okay.